Hello everyone, thank you for watching my second video on the statistical issues. Today I'm going to talk about this famous or infamous term called p-value. So as I said, it is a well-known if not infamous term used in publications in all sorts of studies. So this is the outline of my talk. So firstly, I'm going to talk about the background, the motivation of this talk, and some from historic point of view about this issue. I also talk about the way forward, and I'll draw the conclusion there. Okay, so the background. So recently there has been a lot of debates on the use of p-value, and some scientists call to ban it, and some object. So I'm going to review this issue in this talk. So I remember a few years ago, a academic journal has banned the use of p-value or significance hypothesis testing. It was such an issue then the ASA, the American Statistical Association, has released a statement on the p-value. So if you're interested, you can read this article, which contains much information about the context, process, and purpose of p-value. So it does have clarify a lot of issues or misunderstanding about p-value here. And then recently, to be precise, last year, there was some new criticism on p-value. So as I noted here, there was a very influential commentary published in Nature in 2019 calling for the abandonment of statistical significance, and it was signed by hundreds of scientists. And I think this paper actually is like a review of these petitions and as well as p-values, the use of p-values in scientific work. So before we dive into some details, we need to understand the foundations of statistics. So there are four major statistical paradigms. So the first is mostly often used frequencist. So one of the big part is non-hypothesis significance testing, HST. So this is a mostly often used approach. There are of course there are other approaches as well. For example, Bayesian approach, information strategic approach, likelihood-based approach. I'm not particularly familiar with this likelihood-based approach, but for Bayesian and information strategic approach, one can choose to avoid p-value altogether, because p-value is really very much a frequencist concept. So what is a p-value? P-value is a probability of data given the non-hypothesis is true. Okay, but the problem is it can be useless and difficult to interpret. When you think about it, isn't it better to calculate the probability of the hypothesis given the data? Right? I think this is more straightforward. a researcher collected some data, and based on the data, they want to make a statement of their research question. So they want to know the probability of their hypothesis given the data instead of probability of data given the hypothesis, not the other way around. So I think the p-value is quite difficult to interpret, and so that's why it caused much confusion. But the p-value does not answer this question, this probability of hypothesis. But Bayesian and information theoretic approach can answer questions like this. And then there is a logical problem of p-value, given the definition we just discussed. So here is how we usually use the p-value. So firstly, we say that if the null hypothesis, typically it is about there's no treatment effect, or effect is zero. So if the null hypothesis is true, what is the probability of observing such data? So if the probability of observing such data is very low, so typically 0.05, so this is the very typical threshold we used for p-value. If it is less than 0.5, we say the effect is statistically significant. So if the null hypothesis is true, then if the probability is observing such data is very low. But the problem is that we did have observed such data. So let's review this logic here, the flow of logic here. So if the null hypothesis is true, but the probability of observing such data is very low. But the truth is, we did have observed such data. We collected data, and we collected such data, and we observed such things already happened. So that means that the null hypothesis is probably wrong. So we conclude that the treatment is effect. So do you understand this process? So it basically says that if we assume the null hypothesis is true, then we calculate the p-value, which is maybe very, very low, which means that the probability of observing the data like this is very low. But we did have observed such data, so the problem probably lies with the null hypothesis. It probably means that our null hypothesis is wrong. So we conclude that the treatment is effective. But there's a logical problem in this thought process. So Cohen had the following example. So assume that if a person is American, this is our null hypothesis. If a person is an American, then he is probably not a member of Congress, right? Yeah, I think this is true. Absolutely majority of Americans are not members of Congress. So this statement is absolutely true. So if a person is American, then if you ask me, then I will say he's very likely not a member of Congress. But if this person tells me he or she is a member of Congress, this means that we have observed a data which is very unlikely to happen. Then, based on the logic we just discussed, based on this logic, we would conclude that this person is not American, which is absurd, right? So this is a logical problem of p-value. How we get here? So we need to look at some historical aspects about this p-value and NHST. The NHST, the whole thing seems confusing. I mean, this is true when I talk to my colleagues or students, and when I was a student, when I started to learn these sort of things, I was also a bit confused. Well, actually, there are some historic issue involved in this. Despite the name, remember the term is non-hypothesis significance testing. Well, actually, hypothesis testing and significance testing were actually very different and competing concepts. So Fisher, many of them probably have heard of Fisher's exact test. Fisher is the often credited as the father of modern statistics. So he proposed this p-value and significance test. On the other hand, around the same time, Neyman and Pearson proposed the hypothesis testing. So one proposed a significance test, one proposed a hypothesis test. The hypothesis test involved notion of alternative hypothesis, and it also helped to know that Fisher and Neyman were very bitter adversaries throughout their careers. Okay, so this table from this article present a very nice differences between Fisher's approach and the Neyman-Pearson's approach. So in terms of arrangement of a hypothesis, Fisher's approach says that there is a single non-hypothesis, whereas in Neyman-Pearson's approach, we have two hypotheses. So it's like the treatment is effect or the treatment is not effect. So in Neyman-Pearson's approach, there are two hypotheses, whereas in Fisher's approach, there's only one single hypothesis. And then Fisher's approach says that if PDH, so this is a probability of data given hypothesis, if PDH is really small, again, typically less than 0.05, if the PDH is very small, then the hypothesis is rejected. Okay, but if the PDH is not small enough, then the hypothesis is not rejected, but it is not accepted either. So it's neither rejected or accepted if the p-value is not small enough. However, in Neyman-Pearson's approach, their approach says that if the PDH is small, so the tested hypothesis is rejected. So this is the same. But if the PDH is not small, it's larger than some threshold, then the tested hypothesis is accepted. So we have to highlight the tested hypothesis is accepted, and the alternative hypothesis was rejected. So one says that we should not accept it, the hypothesis if the PDH is not small enough. But on the other hand, this hypothesis testing by Neyman and Pearson says that we should have accepted the hypothesis. So this is the different approaches by Fisher and Neyman-Pearson. So Neyman-Pearson's their approach is based on decision-making situation. So I can understand that why they have this conclusion that if the PDH is greater than a certain alpha value, then we have to we would accept the hypothesis, because this is about decision-making, right? So today's approach, as you can see, some of the notions like two hypotheses, non-hypothesis and alternative hypothesis, two hypotheses, and the notion of p-value. Today's approach is really a hybrid of Fisher and Neyman's approaches. Although some say that it is an astonishing worth of both. Hybridization of Fisher significance testing and Neyman-Pearson's alpha level hypothesis testing is the worst of both, right? So this is interesting, and this author will also claim that neither Fisher or Neyman and Pearson would approve this hybrid. Okay, so we have this interesting situation that Fisher and Neiman, they proposes two really competing ideas, but then we have this hybrid that no one would have approved. So this is an interesting situation. I think that that's some historical roots why we had this such confusion and misunderstanding. So what can we do about it? Given that there was so much criticism about this p-value, you can read that this journal, the paper, the article published in Nature. So yeah, there was some valid criticism about p-value, but I'm afraid to say that there's not much you can do about it, because one of the reasons the criticism of p-value is nothing new, and the recent movement is not the first, nor will be the last. So for example, let's look at this article. So this article is published in 1994, okay, 1994 article. So what this article says, after 4 decades of severe criticism, 4 decades till before 1994, okay, so this means that it's already more than 60 years, 6 decades, 60 years of severe criticism, but still p-value is still widely used. So one of the reasons p-value is still widely used is easy to use, and is an output of standard software packages, and it has many. As I mentioned before, there are alternatives like Bayesian approach, but Bayesian methods typically require simulation, and also, which means it can take a longer time, more complicated to run, and sometimes requires a higher level programming skills. So there's certain barriers of using Bayesian methods. It has been improved very much since last few years, but still there are some barriers. So what can we do about p-value? So there's really not much, and as I said, criticism of p-value is nothing new. The recent movement is not first, nor will be the last. Some journals have, this journal have totally banned the use of p-value and HST, including confidence intervals, altogether. But it is very rare. So most journals still, I have to say, absolutely most journals still accept papers with p-value and HST. But they have some journals have devised some guidelines for you to follow. Some journals, some guidelines more detailed than others. For example, I came across a journal which just says that in addition to p-value, you should report confidence intervals as well. So okay, this is fine, and but some journals have more detailed guidance. So we are going to look at one example. So the example we are going to look at is the guideline by the New England Journal of Medicine. So this is a well-known journal, well-known medical journal. So I have extracted some of their guidance regarding to p-value and significance testing. So it says that significance tests should be accompanied by confidence intervals. So this is quite standard among many journals. So they require you to report confidence intervals as well, in addition to p-value. And it also says multiple testing problems should be addressed in a pre-specified. So this is a very important pre-specified statistical analysis plan or protocol. For example, using Baffaroni adjustments or false discovery rate. Okay, so this is because that I think partially because of p-hacking, this term p-hacking exercise. So researchers, authors, they just look at dozens or hundreds combinations test, and one of the tests ought to be significant, but this is just a false discovery. So that's why we have this false discovery rate or Baffaroni adjustment to adjust this. But so it's better to have this pre-specified SAP or protocol, so to ensure that authors are 100% honest about their analysis they were going to do, instead of they were doing hundreds of tests and they only reported one, pretending they have only tested it once. So this is not good practice. However, the above practice does not apply to significant tests of safety outcomes. So if it is about safety, about this precaution problem, then so this requirement is not it can be relaxed for safety reasons. And if not pre-specified, so the New England Journal of Medicine says the p-value should not be reported, but confidence intervals are still allowed. Okay, so this is why I always say that it's important to discuss with your statisticians before planning a study. So if you have planned a study, you have SAP, you have this protocol, and then in a journal paper, you could present your p-value, and you can claim that you have indeed found a significant effect. Otherwise, you may not even allow to report or present your p-value. So I think we need to follow the best guidance, because sometimes the journal you are going to submit does not require you have a pre-specified SAP or protocol, but your paper could be rejected, and when you submit to a new journal, another journal, they may have this requirement. So this point is very important. So in conclusion, it is safe to say that based on what happened during last 60 years or more, it is safe to say that p-value will still be with us, will still be used for many decades, for some time, quite a while ahead. But my advice is to follow the guidance from publishers, so to increase your chance to be accepted or make a claim. And researchers may also consider switching to other approaches, such as Bayesian approach I just mentioned, and information theoretic approach. So unlike Bayesian approach, this information theoretic approach is quite easy to be honest. It's quite straightforward. So I highly recommend you to consider this approach. I'll show you the paper regarding this. So here are a list of references I mentioned in my talk. So you can pause the video if you want to look up these papers, articles, and have a detailed look. And finally, here are some I found very useful further readings. And the first article is about the information theoretic approach in statistical inference. So this is alternative to Bayesian or alternative to frequency significant testing approach. So I urge you to, if you're interested, you can have a look. It's quite straightforward and easy to implement. Okay, so this is the end of my talk. Thank you for your time.